Hello friends, welcome back to the PorePressure Calculator video. This is an extension of the last video. So I'm going to put 0.45 as normal gradient and 0.90 as overburden gradient because the data that I'm going to use in this video has a higher overburden gradient. Okay, select data. This data demo123 dot back tr and demo123 back tr1 are two datas of the same data set. This one has data up to 5950 because after 5950 there is a big shift in the resistivity trend, and therefore in order to have a shifted resistivity trend line, there is a second data formed after 5950. Okay, first data of the first data set. Okay, it is a bit slow. Okay, 5, 10. This lithology filter helps to demarcate various lithologies based on gamma ray response. 10.01 to 30, 30.01 to 40, 40.01 to 75, 75.01 to 130, 180.01 to 220, 130.01 to 180. And the resistivity filter helps to filter out noisy resistivities that doesn't form part of the major data. And those spiky, noisy resistivities doesn't contribute to consistent trend. And therefore, that interval has to be identified so that a smoother curve in resistivity plotting as well as valid values for pressure estimation is identified. So for this data, I have taken 2 as the resistivity filter. Okay, now see the data. One can see that generally there is an increasing trend. After 4,780, there is a 770, there is a drop. So this must be a major area of under compaction. Yeah, let us see. And yeah, here it is generally dropping. Uh, and from here onwards, there is a shift in the trend for the pore pressure. It has started an uptrend here and again downtrend here. Okay, here comes our uh, added feature, the lithology. Okay, so this plot has various features such as zooming. Okay, zoom it, and the finer details of each column, each curve are visible much more clearly and much more in a granular fashion. Okay, so lithology also can be seen. It can be even more zoomed, but for now I'm not doing that. So further, we can scroll the zoomed zoomed screen down or up. Okay, okay. So similarly, it can be scrolled up also. So this is the purpose, and so far that's enough. And let me go to the second uh, data of the first data set. Okay, select the second data. Okay, okay. The second data is selected and trend is again applied. See, since I have not changed the resistivity filter, it is not plotting. Resistivity is about 2. So I have to do that. Okay, I'm going to take it as 20 and then again apply it. See, this time it has plotted um, values about 2, and generally the trend is, say, contributing to a consistent trend. The range is from 2 to, say, 15. So 20 is a good enough range. Okay, here the new feature is plotted. Generally, it is mainly sandstone. Uh, and at the bottom portion, it's mainly sandstone. So, kind of, uh, the reservoir is ending here, maybe. I don't know. I'm not sure about that. So, I don't want to dig deeper into the interpretation side. So, let me select another completely different data for which I want to select a filter of 1.45. So there is this data that I have selected, and the overburden gradient for that one is 0.65. Okay, here it is plotted. Generally, it is an increasing trend. There is no significant undercompaction as such, except there is a slight undercompaction in this area. Probably. Let's see what the plot says. Yes, generally it was dropping up to here, and there is a rather kind of minor increase in the pore pressure. Okay, and towards the end, it is again dropping. See, generally it is dropping trend. See, this is the lithology for this well, for this data set. So it's mainly limestone and dolomite with the minor intercalations of sandstone. So that's about the new feature added. Thank you for watching. Thank you for your support.